On July 17, 2025, NASA achieved a critical milestone that brings us one step closer to unlocking the infrared secrets of our universe. The Nancy Grace Roman Space Telescope received its cosmic sunblock, two massive sunshields that will protect its sensitive instruments from the sun's overwhelming heat. Set to launch by May 2027, Roman is NASA's next-generation infrared observatory, designed to peer deeper into space than ever before. But to detect the faintest infrared signals from distant galaxies and exoplanets, Roman needs protection from our sun's intense radiation. Each sunshield is an engineering marvel, a 7x7-foot aluminum sandwich, just 3 inches thick, weighing as little as possible while maintaining incredible strength. The structure consists of ultra-thin aluminum sheets, as thin as a credit card, sandwiching a lightweight honeycomb core, topped with a 17-layer polymer film blanket. This design creates an extreme temperature gradient, from 216 degrees Fahrenheit on the sun-facing side to minus 211 degrees on the protected side. About an hour after launch, these shields will deploy using precision dampers, like soft-close cabinet hinges, taking 2 minutes per panel to unfurl without disturbing the telescope's delicate instruments. But why infrared? Unlike visible light, infrared radiation reveals the universe's hidden thermal signatures, from the heat of distant stars to the warm glow of exoplanet atmospheres. Infrared light penetrates cosmic dust clouds that block visible light, revealing star formation regions, galaxy cores, and ancient lights stretched by the universe's expansion. While James Webb uses a tennis court-sized sunshield for ultra-deep observations, Roman's compact design enables wide-field surveys, mapping billions of galaxies in unprecedented detail. Roman's field of view is 200 times larger than Hubble's, allowing it to survey vast cosmic regions while maintaining the infrared sensitivity needed for breakthrough discoveries. Protected by these sunshields, Roman will tackle cosmology's biggest mysteries, mapping dark energy's influence on cosmic expansion and discovering thousands of exoplanets. The telescope will observe 100,000 cosmic explosions, survey billions of stars for planetary systems, and peer into the atmospheres of distant worlds. With sunshields installed, Roman moves into final testing phases, bringing us closer to a new era of infrared astronomy. These engineering marvels, Roman's cosmic sunblock, will soon shield humanity's next great leap in understanding our universe. The infrared cosmos awaits.